Hello folks, this is a 2024 October-November paper 4-3 and the question number is 10. It is concerned with the chapter Astrophysics and Cosmology. The first question is explain how redshift leads to the idea that the universe is expanding. First of all, this redshift means it is the increase of wavelength of the radiations coming from the stars. And according to Doppler effect, this increase in wavelength means increase in lambda means that according to Doppler effect, those things should be going away. The stars should be going away. So that means the stars should be going away. They should be going away. And when we observe almost all of them are going away. And this is only possible if the universe is right now expanding. Expanding. All of them going away means that right now all of the things should be expanding. So that's the answer to this question. Then, stars in a distant galaxy emit radiation. The total luminosity of the stars in the galaxy is this much. So this is the value of this L. The emission spectrum of the radiation contains a line X at a wavelength of this much. So this thing is lambda. This is lambda. So radiation from the galaxy is observed on the Earth. The observed radiation has a radiant flux intensity of this much. So this is the flux intensity. It's equal to F. This is F. In the observed emission spectrum, line X is at a wavelength of this much. So this is lambda prime. This is the lambda that is observed by the device here. Now determine. So what we should be doing is determine the distance d of the galaxy from the Earth. So now what we have is they say F is equal to area, and that's equal to L by 4 pi d squared. 4 pi d and then squared. So which gives us d squared is equal to L divided 4 pi f, and that's equal, or I can say d is equal to root L by 4 pi f. Now that will give me, so this L is equal to 1.9090 into 10 to power 36, and here it is a 4 pi into 8.42 into 10 to power minus 16, and it is root here, it is whole root here. Now if I do calculations, it will be equal to so 1.9 exponent 10 to the power 6 divided bracket 4 into pi into 8.46 exponent minus 16 equals equal to power 3.5. So it's equal to 1.322.863 into 10 to power 25. So that's equal to 1.332 into 10 to power 25 meters. Okay, then next question is the speed v of the galaxy relative to the Earth. Speed v of the galaxy. So it's given by, so delta lambda by lambda should be equal to v of the source divided this c. Or I have this v of the source is equal to delta lambda by lambda into c. So delta lambda is it's equal to 726 minus 658. So it is 726 minus 658 divided 658 into the c is 3 into 10 to the power 8. Okay, this will be equal to 726 minus 658 divided 658 into 3 8 is equal to 3.1003 into 10 to power 7 meters per second. So that's equal to 3.1 into 10 to power 7. So it is 3.1 into 10 to power 7 meters per second. It's almost equal to 1/10 of the speed of light. Then observations of many galaxies, such as the one in B, leads to many pairs of values of D and V. Plotting these values reveal a trend. So on figure 10.1, sketch the variation of V with D. So the graph should be a straight line. According to Hubble's law, the graph should be a straight line. So it should be equal to a straight line like this. So straight line. Yeah. Now, state the name of the quantity represented by the gradient of the line. So we have to represent the quantity. So what we have is this V and D are related as they are proportional to each other. This gives us V is equal to this Hubble's constant into D. So that means if this is in x-axis, if this is in y-axis, it should be equal to the slope. So that's why the gradient should be equal to the Hubble's constant. So it is the Hubble's constant. It is equal to the Hubble's constant. Hubble's constant. So Hubble's constant. So this is the answer to this question.